Welcome to our next video in the Monte Carlo video series. My name is Brittany, and in this video, I will introduce you to some of the ways we can utilize Monte Carlo methods for inference. We will focus on two areas, utilizing Monte Carlo methods for estimation and for hypothesis testing. So let's get started by discussing some of the different ways we can use Monte Carlo methods for estimation. Monte Carlo methods can be applied to estimate a parameter of a sampling distribution for statistics. For example, we could estimate the mean difference between two samples. We can also estimate the mean square error, or MSE, which is basically just the mean of some function of numbers. First, it's important to remember that the mean square error, or the MSE, of an estimator theta hat for parameter theta is defined as the expected value of theta hat minus theta squared. We can estimate the mean square error, or MSE, using Monte Carlo samples. If m random samples are generated from the distribution of x, no matter what the distribution is, then the Monte Carlo estimate for the MSE is 1 over m times the sum of theta hat from the random samples minus theta squared. We can estimate the MSE by using the following algorithm. First, we'll generate x1 through xn from the distribution of x and use this to compute theta hat. And we'll do this 1 through m times. Once we have simulated these theta hats, we can use them and plug them into the equation to compute the mean square error of theta. To illustrate using this algorithm, we will be estimating the mean square error of sigma in a normal distribution x1 through n, which is IID normal with mu equal to 100 and sigma squared equal to 13 squared. We will use R to create n estimates of sigma MLE and use that in our calculation of the MSE of sigma. So our goal here is to estimate the mean square error, or MSE, of sigma, and in this case we're going to utilize the MLE of sigma. And our distribution is a normal with mean mu and sigma squared. So what we'll do first is we'll load in the values of mu and sigma. In this case, mu will be 100 and sigma will be 13. In this section here, we're going to talk about the MLE and create a function for sigma hat, our estimate of sigma, which is the square root of the sum of my sample minus the mean of my sample squared. And we're going to divide that by the length. And then we're going to return sigma hat. All right, so we created our MLE function. Next, what we're going to do is create a function g of x. And in that function, we're going to have x minus sigma squared. So we'll do that right here. Run this code. All right, so all these things have loaded. Next, it's important to distinguish that n is the number of MC iterations and m is the normal sample size. So those are two different lengths that we should be aware of. So we're going to create the MC estimate with this function here, and that's going to create a matrix. All right, so we returned. All right. So what we get returned by running this function is the mean of g. So g bar. When we run this section, we'll have the Monte Carlo estimate of the MSE. So we utilize n equal to 1,000, so that's 2,000 iterations. And then we used m equals 10, so our normal sample size is 10. So this gives you one estimate of the MSE. If we run it again, we'll get something that's similar, but a little bit different because it's a new MC estimate. We can keep running it and see that it's generally about 9. Instead of running each of this separately, we can replicate the function 1,000 times. And then if we go down to here, we can plot those 1,000 replications. Though the replications do take a little bit of time for R to run. All right, Now that those replications have run, let's plot it. And we can do that with a histogram. And that'll appear right here. All right. So it looks like, as we could kind of tell by running each of the MC estimates, that it appears to be generally about 9, a little bit over that, maybe 9.25. And you can see the distribution of those 1,000 replications right here for the MC estimate of sigma. And then one last thing, it's really easy to look at the standard error of this Monte Carlo estimate. If we do a good estimate, we can use the standard deviation of the Monte Carlo estimate, and by writing SD of MC dot E. We can get that the standard error is about 0.26. And with that, we're finished with our first video on Monte Carlo methods for inference for estimation. Watch part 2 to learn a little bit more about how we can use Monte Carlo methods for inference for hypothesis testing.